So in this lecture we will study about a term that is known as support vector machine. Okay, so what is a support vector machine? So support vector machine is a classifier or predictor which can classify linearly separable binary sets. Okay, so basically it is a separator which can classify linearly separable two binary sets. Okay, suppose you can see that a graph is there. Okay, so here suppose circles are there and a square group is there. Okay, so we have to find a line between them so that they are separated by a maximum distance. Okay, so the main rule is to find a line, or that will be called as a hyperbola, to divide the two linearly separable binary sets. Okay, suppose it is a feature for a substance, okay, or material or a thing, okay, x1, and this is a feature x2. Okay, so this is a group and this is a group, so we have to find the line or hyperbola between them that may be drawn like this. Okay, so this one, okay, so this line is called as a hyperbola. That is, hyperbola is mainly defined here to represent the separable line between the two sets. Okay, so for that we have to find the equation for this hyperbola. Okay, and from the equation we can draw a line. Okay, but how to find the hyperbola? Okay, and one more thing, so this is a set we are finding, and we may also get a set like this. Okay, so from this set 1, okay, and this one, okay, 2, so which one is more separable? So we, from this figure we can see that this one is more separable. Okay, suppose the total distance here is d. Okay, then the distance d can be represented as z plus z, that is 2z. So here this distance is z and this distance is also z, so that becomes 2z. Okay, so here we can represent the distance as a 2z. So this has also a distance, okay, that may be d dash. Okay, so here from this model we can see that d is greater than d dash. So we will select this hyperbola h1, okay, as the line, okay, which divides by a maximum distance. Okay, this width, getting, this is the width. Okay, so now what is the equation for hyperbola? So we know that so the equation for hyperbola can be represented as gx vector plus w0. Okay, so transpose dot x plus w0. So this is the equation for hyperbola. Getting? So here we can see this is a weight vector and this is the feature. Okay, so what is a weight vector? Weight vector here is mainly used for the displacement of the line. Okay, this line. Okay, this line, displacement of the line. Okay, for displacement, and this line is mainly used and this is a vector x, and this is called as bias. Okay, this is mainly used for rotation. Okay, so this is for displacement and this is for rotation, like this. If you are rotating like this from this point, okay, if you are rotating like this, so the rotation can be done using bias. So this is a complete equation for the hyperbola, and we have to find the equation for the hyperbola. Okay, so from this equation we can see that the value of z can be represented by gx by w. Okay, so here z is a distance. Okay, and in hyperbola we can calculate the distance, okay, z by this equation. So this can be represented as, and the value of gx will be at least 1, so we can represent this by w. Okay, so if we are writing this again, then 2 into 1 by w is equal to 2 by w, getting 2 by w. So here we can see that this equation, okay, 2 by w, that will be d, that is d. Okay, so here our main problem is to maximize the distance between them. So if we are reducing this term, okay, if we are reducing the weight vector, then the distance will increase, and this will decrease. Getting? So our main aim is to reduce the weight vector, because these are inversely proportional. The distance is inversely proportional to the displacement, okay, the weight vector. So that's why we will decrease this, and the value of d will be increased. So this is the basics of support vector machine. Okay, so finally we will solve a problem, okay, which will give you a complete picture of support vector machine. Getting? So we will go for a problem now. So finally we will solve a problem by getting this. Okay, so now we will solve a problem related to two-dimensional, okay, that will be 2D. Okay, so in 2D we have previously represented a graph, okay, that is like this. Okay, so this is a question, okay, to separate the things. So this will be 0, suppose, okay, x1, then x2, then here a point is there. Okay, so here one thing is there. Okay, so and here a square is there. Getting? So it has a coordinate of 2, 0, okay, and it has a coordinate of 1, 1, okay, and it has a coordinate of 2, 3. Okay, so first of all we have to find, so these are circle groups and this is a square group. Okay, so first of all we will take one thing, that if we are drawing a line between them, so the upper part is class 1, we can represent it by class 1, okay, and the down part, okay, the down part is called as class 2. Okay, so this is square part, and this is our circle part. Okay, so for this class 1, okay, for class 1, the rule says gx, okay, should be greater than equal to 1 for all x belongs to class 1. Okay, then another rule, this is rule number 1, and the rule number 2 is gx less than equal to minus 1 for all x belongs to class 2. Getting? Belongs to class 2. Okay, so here we can see that this is the equation for this part. Okay, for this part we will take gx is equal to 1, for this part gx is equal to minus 1 class 2. So this is the rule says only. So this is a rule by the equation of hyperbola. So finally we will add these equations in this to find the line between them. Okay, so for that what we are doing, we will take the equation first, gx, okay, is equal to wtx plus w0. Okay, so here we can see that first of all we will find a weight, okay, that may be here. Suppose a line is here, okay, so it can be represented like this point. Okay, we can find this point by minusing this 2 comma 3, by subtracting 2 comma 3 minus 1 comma 1, that will be 1 comma 2, or it can be represented like a comma 2a. Okay, a comma 2a. So after that we will solve. So this will be now considered as the weights. Okay, by subtracting this. Okay, this is now temporarily considered as the weights. Okay, so now we will find the transpose. Okay, that you can see the point is the weight. Okay, the point is a 2a. Okay, then 1 1. Okay, for this point I am finding, okay, because this point is nearer and this point is nearer, so we will find the nearer point group, between the distance between the nearer points. Okay, how much they are separable. Okay, so plus this 1 comma 1 plus w0 is equal to minus 1. Okay, so you can see that I am getting here minus 1 because this is in this group. Okay, so this is called as minus 1. Okay, so if I am solving it, okay, a, and this is transpose, so this will be converted to like this, then 1 1 plus w0 is equal to minus 1. Okay, so finally we will get the equation of this as of 3a plus w0 is equal to minus 1. Okay, is equal to minus 1, and w0 is equal to 3a. Okay, minus 3a plus 1, minus 3a plus 1. Okay, this is for 1 comma 1. Then we will add this. So this is our equation. Okay, we will find the equation that will be equation 1. Okay, this will be equation 1. So now we will add this in equation 2. Okay, so finally in equation 2 we are getting like a 2a, okay, transpose 2 comma 3. So this point I am taking 2 comma 3 plus w0 is equal to 1, because this is in this class gx. Okay, so finally we will get w0 is equal to 1 minus 8a. Okay, that is equation 3. Okay, before that we will reach a step, that is 2a plus 6a plus w0 is equal to 1. Getting? So now we will put equation 3, okay, in 1. Getting? So this will be 2, and now we will put equation 3, this one, in the equation 1. Okay, so after putting that, we will get, okay, that is a plus 2a plus 1 minus 8a is equal to minus 1. So that value of a will get is 2 by 5. Okay, the value of a is now 2 by 5. Okay, this value of a is now 2 by 5. Then we can find the weight vector. From this. Okay, find the weight vector. W is equal to a comma 2a, that is previously, so that is we get 2 by 5, so this will be 4 by 5. Okay, so now the weight vectors are 2 by 5 and 4 by 5. So these are called as the support vectors. Getting? So after that we will do one thing, then we will put that in equation 3. Okay, these values in equation 3, that is w0 is equal to 1 minus 8a, so that will be 1 minus 16 by 5, so that w0 is equal to minus 11 by 5. Okay, now finally we will put the values of w0, okay, w0 and wt, okay, and this x, that is x1 x2, to find the result for the equation. Okay, so that will be a, so gx is equal to a2a, then x1 x2 is equal to minus 11 by 5. Okay, that is minus 11 by 5. Okay, so this equation we are putting. Okay, this value we have already found, and this value we don't know, x1 x2, and minus 11 by 5 we found the value of w0. Okay, so finally you will get the equation, okay, that is gx is equal to x1 plus x2 2x2 minus 5.5. So this is the final equation of the hyperbola. Okay, so this equation is perfectly set here, okay, in this graph, so that we will get a good maximum separable between the two binary sets. Okay, so these are the basics of support vector machine. So when we are adding a thing that is SVM, that is analysis, okay, SVM analysis, we are going for SVM using the regression. So what is the regression here? So regression, we know that regression is the relation between the input vector, okay, and the output, input vector and the output, okay, output y. So here we can see that our output or the response is our gx, okay, and our input vectors are x1 and x2. Okay, if we are using this in this equation wt, okay, x1 x2 plus w0, then we are finding, and this is called response y and this is x. So here we are getting a relation between them, okay, to find the line. So this is called the regression in SVM. Okay, so this is finally the basics of support vector machine. So in future we can go through many problems by using this algorithm of SVM in the machine learning techniques, by which we can learn a machine to find a classifier, okay, so that it can separate the sets, okay, in a with a high accuracy. Okay, so thank you.